get some of that done. Laws of logarithms. Logarithms have properties, and here's the first property. You could take a log with a base a of a times b and separate it to log base a of a plus log base a of b. So you could separate the two. Turn it from multiplication into addition. From one logarithm into two. Now you might be like, why is that true? Well, if you have x to the a times x to the b, that is the same as x to the a plus b, correct? It's really the same type of property that you added the exponents with one base. Here you were multiplying with two bases. So it's that's really what you're saying, okay? So what do you think happens if I divide them? Very good. Log base a of a minus log base a of b. What happens if you take a power to a power? What do you do to the exponents? So we're going to take this c and we're going to move it out here, c times the log base a of a. So you could take an exponent and move it out front of the logarithm. Those are the three properties that we are currently going to use for logs. So the front side is the first examples that you're going to see on your worksheet. Use the laws of logarithms to rewrite the expression in the form with no logarithm of a product, quotient, root, or power. I currently have the logarithm of a product. I want to separate that. How could I separate that? Log of 5 plus log of 3. Any question on that one? Next one, log of 3 plus log of 4 squared plus log of 5 to the 6th. That's the first step, but it's not simplified because you can't have a quotient, root, or power. Does anybody know what I do next? Very good. These dump here, and this dumps here. Now you have log of 3 plus 2 log of 4 plus 6 log of 5. Try the next one on your own. Talk to a partner. Check. There's a couple different answers you could come up with. Don't be afraid to make a mistake. Okay, I have the answer up here on the board. The first step is to move the 3 in front, and then it's the log of 4 over 7. So it's 3 times the log of 4 minus the log of 7, or 3 log of 4 minus 3 log of 7. Either way you have it. But this is a good problem because it teaches you a couple things. Number one, you have to move the 3 out front first. And here's why. When you begin to separate these, you do the opposite reverse order of operations. So you've been doing this your whole life. 2x plus 1 is equal to 7. How do I solve that? What do I do first? You subtract 1. Why? You just always done it. But why? Well, here's why. If you look at the order of operations here, if you were to plug something in, say 3, you would do 2 times 3, and then you would add 1. So when you solve equations, you move in the reverse order of operation. So look at your order of operation here. Would I take 4 to the 3rd first, or would I take 4 divided by 7 first? 4 divided by 7. And after you come up with that, you then raise it to the 3rd. So raising it to the 3rd was the last operation, so that's the first thing that you undo. Then you move on to the next piece. Now here's a second thing to consider. Is 4 being taken to the 3rd power? Is 7 being taken to the 3rd power? Or both being taken to the 3rd power? Both. So notice you have a 3 in front of both of them. And finally, look at this. Is the 4 in the numerator or denominator? Numerator. So it comes out as positive. Is the 7 in the numerator or denominator? So it is negative. If it's in the denominator, it has a negative exponent. Logarithms solve for exponents. That's why it's negative. Okay. All right. Good job. Let's try a couple more. Log base 3 of square root of x squared minus 5. Looks super complicated. We're going to make it super easy. log base 3 of x squared minus 5 raised to the 1/2 power. So a square root is just another way of writing a power. What do I do with that power of 1/2? Where do I put it? Out front. And I get 1/2 times the log base 3 of x squared minus 5. Awesome. Some of you would like to now deal with this, but you can't. Because look at the order of operations. You square something, then you subtract 5. Can we undo subtracting 5? No, you can't. There's nothing to undo subtraction as you look at your properties. We can undo addition or multiplication. We can undo division. We can undo powers, but you cannot separate it when it has subtraction or addition. Try letter E on your own. This one's tough. Okay, your first step is to separate it like that because you're going to undo the division first. Because in the order of operation, that's the last piece that's set up. Now, here's the obvious one. If you knew to move the 3 out front, good. But I can't move the 4 out front. And here's why. Is 2 being taken to the 4th power? No, only the x is being taken to the 4th power. So therefore, you must separate it like this. The natural log of 2 plus the natural log of x to the 4th minus the natural log of x minus 2 to the 3rd. Now you can move the 3 out front. Now you can move the 4 out front because, as you can see, the 2 is not being taken to the 4th power. So most common mistake is that people would put the 4 in front of the natural log of 2. We have the natural log of 2 plus 4 natural log of x minus 3 natural log of x minus 2. And finally, the last one. I'm going to write it as the natural log of 4x squared over 2yz, all raised to the 1/3 power. Any thoughts on what we can do first? Yep, drop that 1/3 out front. Uh-oh. I think the smart board got mad at me. There, yep. Turned red. Angry face. There it is. 4x squared over 2yz. Cool. All right. So the 2yz is in the denominator. So all those terms should end up being negative. And the 4x squared, all those terms are in the numerator, so they should all be positive. So we have 1/3 times the natural log of that 4x squared minus the natural log of 2yz. I'm going to separate the natural log of 4x squared, 1/3, times the natural log of 4 plus the natural log of x squared. As I separate the 2 and the y and the z, I'm going to need to distribute that negative all the way through. Minus natural log of 2, minus natural log of y, minus natural log of z. What's the last thing I need to do in order to finish this off? There's one piece up there that still needs switching. The exponent. So 1/3 times the natural log of 4 plus 2 natural log of x minus the natural log of 2 minus natural log of y minus natural log of z. Again, you guys, I know we always make mistakes. I make mistakes, everybody does. But when you're on the test and you see that these are in the denominator, but you don't have them as negative, to me that's an easy check. You can say, oh, I have a mistake. These are in the denominator and I have something positive. That's a problem, okay? So those are kind of easy checks. You might miss something else, but that's That's a pretty good indication. Okay, flip it over. That's usually the harder part. This is usually the easier part. Now it says write it as a single logarithm. So you can see we have 2. Well, instead of adding, we could write it as log base 2 of one thing. And what do we do? What do you think? Yeah, we multiply them. 5 times 7 is my 35. Nice and easy, right? The next one, there's a slight little trick here. I'm going to write it as 2 log base 5 of 3 minus 1/3 log base 5 of 64. Because dividing by 3 is the same as multiplying by 1/3. So what do I do with the 2, and what do I do with the 1/3? Let's move them on up here to the exponents. So now you have the log base 5 of 3 squared minus the log base 5 of 64 to the 1/3. Three squared? 9. 64 to the 1/3. The cubed root is 64. 4. And now instead of using subtraction, we can use division. Log base 5 of 9/4. Try letter C on your own. Try letter C on your own. It's a good problem. Okay, after teaching this class for many years, there's a mistake that I generally anticipate that people make. Usually people put the square root of 2 in the denominator. Okay, would be very normal. Say, well, I have 16. I'll divide by 8 times the square root of 2. But the fact is that the natural log of 8 is the only one that's negative. It's the only one that belongs in the denominator. All the rest belong in the numerator. And so therefore, we got it just like that. Okay. Try D on your own, and I would like you to start by distributing the 3. Distribute the 3 and see what you come up with. Okay, let's see what happens. 3 natural log of x plus 1 plus 3 natural log of x plus 2 minus 6 natural log of y. What do you then do with the coefficients out front? Yep, you move them up into the exponents. So we have the natural log of x plus 1 to the 3rd plus the natural log of x plus 2 to the 3rd minus the natural log of y to the 6th. Since these are positive, they'll be in the numerator. Since this is negative, it will be in the denominator. That's an amazing sound. Natural log of x plus 1 to the 3rd times x plus 2 to the 3rd over y to the 6th. I want to be clear about one last piece before we move to the last examples here. Natural log is an operation. You could think of it as the square root. And so some people make mistakes here. Here's what they do. Imagine if we wrote this as a square root right there, or a square root at the bottom. You'd be like, well, no, the square root has to cover the whole stinking thing, right? So people are like, does the natural log go at the top or the bottom? Or do I put one for both? Folks, it's the natural log of that whole thing. Okay, that's what we want. Okay, it's not like the natural log goes to the top or bottom or anything like that. All right, our last examples. These are going to be fun, and they're going to be easy. Log base 2 of the root of 32. For those of you who took the ACT already, raise your hand if you've taken the ACT. This would be one type of question that you would see on the ACT. Some of the ones we've seen before, but they really these are good test questions that they like to use. And the first thing I'm going to do is I'm going to rewrite this as the log base 2 of 32 to the 1/2 power. And I'm going to use the laws of logarithms to simplify these. The first thing I'm going to do is I'm going to move that 1/2 out front. 1/2 log base 2 of 32. What is 32 written as a base of 2? 32 is 2 to what power? 2 to what power is 32? 2 to the 5th. So therefore you can see we have 1/2 log base 2 of 2 to the 5th power. What did we learn yesterday? Cancels. The log base 2 and 2 cancels. So you're just left with 1/2 times 5, which is 5/2. Letter B, log base 5 of 100. I don't know what log base 5 of 100 is, and I don't know what log base 5 of 4 is. But instead of doing subtraction, what can I do? Division. 100 divided by 4? Can I write 25 as a base of 5? Log base 5 of 5 squared. What happens? Cancel, leaving you with dos. Just Spanish for 2. Nice and easy. What should I do first for C? 4 log base 3 of 27. Can you write the number 27 as a base of 3? 4 log base 3 of 3 cubed. It's a lot of 3's. My favorite number. Leaves you with, it's not 4 to the 3rd, it's 4 times 3. This result is 3. 4 times 3 is 12. Right now you're liking that, but the next one, not so much, right? You get the E and natural log stuff together, and all of a sudden your brain goes to crap. And that's really unfortunate because you used to be smart. Well, let's keep you smart, okay? We're going to drop that 3 up top there. So we got E to the natural log of 5 to the 3rd. Holy cow, we got like double exponents going on. Is that even a thing? It is. What's the relationship between E and natural log? They cancel. 125. Take out your calculator. In order to solve this one, you just change the base. You do log base 10 of 14 divided by log base 10 of 6. You press enter, and sure enough, we come up with a number between 1 and 2. We come up with 1.47. It says to round it 6 decimal places. We'll go to 3, okay? You guys got a lot of stuff to do. You got a handy test coming up here, so we'll cut you some slack. I want to be clear. If you chose natural log instead, natural log of 14 divided by natural log of 3. Whoop, sorry, 6. I did that last hour too. Natural log of 14 divided by natural log of 6. You come up with the same piece. Okay? So it doesn't matter which one you choose. Try the next 2 on your own. Go. Compare your answers to a partner. As you're doing it, make sure you put the base on the bottom. This will be the log of 2 divided by the log of 7. I know that 7 to some power is 2. It's got to be between 0 and 1. What'd you come up with? 0.356. Awesome. So that means if you took out your calculator and you want to check your answer, just take 7 and raise it to the 0.356 power. And you're going to come out close. It's not exact, but yeah, it's pretty close, right? You want to do another one? What do you get here? 2 point? Okay, sure. Good. Try it. You take 14, raise to the 2.808, and you get this. Pretty close, you know, kind of. You can see why they want to carry it out to 6 decimal places, right? I mean, much more accurate. That's what happens with logarithms and exponentials. I'm going to end with this as I let you guys go. I know that